Hi guys, I'm just checking the temperature of the tubs that I keep my snakes in. And I see, using this laser temperature gun, that it is about 85 degrees in here, which is perfect for my snakes. Every day I have to check the temperature. Now, you guys are probably wondering, what does this have to do with chemistry? Well, we are starting thermochemistry this week, and as we start thermochemistry, we need to talk about a couple of things, like the difference between temperature that I'm checking with this gun that allows me to check the temperature of things by firing a laser at it, and heat, and then also what is energy. So we've got several different things that are going on in this particular unit. Too many people think that the temperature and heat are the same thing. Temperature and heat are not the same thing. How are they not the same thing, you ask? Well, temperature is what you read on this, say this. If I were to fire at the floor, you can see that it says 70 degrees. That would, of course, be in Fahrenheit. That's because the floor is 70 degrees. That is the temperature of the floor. Temperature is a measure of the average kinetic energy of the particles in something, whether it be a liquid, solid, gas, whatever. Heat is a form of energy. Now, why do I have to monitor the temperature of my snakes? Snakes are not like you. You are a mammal. You can control your heat from inside because there are chemical reactions going on in your body that are what we would refer to as exothermic. That would be reactions that are putting out heat. So you're creating your own heat. Snakes, they're reptiles. They can't do that. So I have to provide heat for them. So I have to set temperature gauges on every one of their cages. And there's a thermostat inside each one that allows me to monitor what their temperature is. But then also, I typically manually check it myself just to make sure that their temperature is just fine. Too hot, and it's bad for them. Too cold, also bad for them. So I try to keep the temperature in their tubs somewhere around 88 degrees at one end and about 75, 78 degrees at the other end. That way they can move back and forth. All right, I moved over to my lab table here in my basement laboratory to talk to you a little bit more about temperature and energy and thermochemistry. While I was over with the snakes, I told you that I constantly monitor their temperature. And that's because I need to know a measure of how much heat is going into their cages to make sure that they are maintaining a particular temperature. How that happens, this is called heat tape. This is typically connected to electrical wiring. I solder wires onto the end of this, and this tape, which is a metal conductor, will start to heat up as electricity flows through it. Electricity flows through it, it meets resistance. That resistance then causes heat. Heat is a form of energy. That energy then is measured when I check the temperature, because I would be checking the average kinetic energy of the particles, the molecules, the atoms that are in this particular strip of tape, which then it transfers that heat to the cage where the snake is. So I have that. One of the things that I mentioned a second ago was that there are chemical reactions that are referred to as exothermic. Exothermic chemical reactions, and if you remember from way back in the beginning of the school year, we looked at chemical reactions to start this year. We looked at some chemical reactions that when you felt the reaction going on in the test tube, that was giving off heat. You could feel that it was giving off heat. It got hot. That's called an exothermic reaction, whenever a chemical reaction gives off heat. When a chemical reaction gets cold, we refer to that as an endothermic because heat would be going into it. Energy is required for an endothermic reaction. So I have a little demonstration to show you here at the lab table of an exothermic reaction. I'm going to back the camera up a little bit and let you see. I've got a block here, and this block, it's just a typical block of wood, nothing special about it. And I'm going to put a little alcohol on this wood, not much, just a little bit of alcohol. And for safety purposes, I've obviously got some water here in case something happens and whatnot. But I'm going to light the alcohol on fire because alcohol will burn. And as you can see, notice safety glasses, the alcohol is burning, but the wood is not burning. It's the alcohol that's burning. Get a little char on the wood, but as the alcohol is burned up, the flame will go out. And the wood is warm. The wood is warm because the burning, as I burned the alcohol, the heat that was released by that burning heated up the wood. So that would be an exothermic reaction. So that gives you a little idea of heat, which is energy, temperature, which is a measure of that energy, the average kinetic energy, kinetic being motion. Think about kinetic energy versus potential energy. So kinetic energy is energy of motion. That motion, obviously, is going to cause heat, which is energy, which I can measure with temperature. Now, complete all of the activities that are in the folder today. Take a look. There is a PowerPoint presentation. There's a brief movie, and then we also have there's a drag and drop activity for you to do to tell the difference between endothermic and exothermic reactions. So hopefully before you finish what you're doing today, you will have a pretty decent idea of things of each of these terms: energy, temperature, heat. You'll also learn endothermic, exothermic activity reactions, and then you'll also take an initial look at something called an energy diagram. So that's today, and then tomorrow we'll learn how to do some calculations. Have a good one.